Your heating bill went up again. You noticed it, you probably said something about it, and then you paid it anyway. Because what else are you going to do? The $1.3 trillion natural gas and heating industry has spent 70 years making sure that question never has a good answer. Here is what they never told you. The physics that heats rooms has not changed since medieval castle engineers figured it out 1,000 years ago. The mechanism is free. The material costs $6. And the reason you have never heard of it has nothing to do with it not working. It works embarrassingly well, and everything to do with the fact that you cannot put a meter on it. $6, all night, no plug. Let me show you exactly how. Your home heating system is doing something genuinely absurd and nobody talks about it. When you turn on central heat, your furnace or boiler generates thermal energy, and then immediately begins losing most of it. Forced air systems routinely lose 25 to 40% of generated heat through duct leakage alone, according to the US Department of Energy. That is not a rounding error. That is nearly half of what you're paying for quietly escaping into your walls and crawl spaces before it ever reaches you. But here is the part that should genuinely bother you. Forced air heating works by moving hot air across a room, and hot air moves. It rises, it stratifies. By the time the thermostat on your wall registers warm enough and shuts the system off, the air at ceiling level is often 10 to 15 degrees warmer than the air at floor level, which is where you actually are. You are paying to heat a room from the top down, in a system designed by an industry that charges you per unit of gas, not per degree of actual comfort delivered. Medieval builders understood something we have been trained to forget. Radiant heat is different from convective heat. Radiant heat does not move through air. It moves through space. It transfers directly from a warm object to a cooler one, bypassing the air entirely. That is why standing next to a stone fireplace feels warm even when the room is cold. The stone is not heating the air around you. It is heating you. The $6 trick works on exactly this principle, and the mechanism is so clean it almost feels like cheating. Here is what actually happens. You take a small clay pot, a standard terracotta planter from any hardware or garden store, 4 to 6 inches wide, and you place a second larger clay pot upside down over it, elevated slightly so air can flow in from the bottom. Inside the smaller inner pot, you place a shallow metal container, an old tuna can, a small loaf pan, a metal ramekin, and you fill it with roughly 70 to 90% isopropyl alcohol. You light it, the alcohol burns clean. No soot, no carbon monoxide at dangerous levels in a ventilated space, minimal odor. The flame produces a modest amount of heat, somewhere in the range of 250 to 300 BTUS, which sounds unimpressive until you understand what the clay is doing to it. Clay is a thermal mass material. It absorbs heat slowly and releases it slowly. As the inner pot heats up, it radiates that heat outward. But the outer pot, sitting over it like an inverted chimney, traps and concentrates that radiated energy before re-radiating it into the room. The gap at the base of the outer pot creates a chimney effect. Cool air is drawn in at the bottom, heated by the clay surfaces, and rises out of the top in a gentle, continuous thermal column. You are building a miniature convection engine. The outer pot surface reaches temperatures of 160 to 180 degrees Fahrenheit within about 20 minutes of lighting. At that point, it is radiating enough heat to meaningfully warm a 100 to 150 square foot space, a bedroom, a home office, a van, without any electricity, any gas line, and without ever consuming more than about 60 to 80 milliliters of isopropyl alcohol over 4 to 5 hours of burn time. 60 to 80 milliliters. At current prices, that is roughly 8 cents of fuel per hour. The chimney effect is not a trick. It is the same convective physics that made Roman hypocausts work, that made stone castles habitable through northern European winters, and that every HVAC engineer uses in their calculations today. The industry did not discover a better version of this. They built an infrastructure that bypasses it entirely, because bypassing it is what creates a billing relationship. In 1952, the American Gas Association, the lobbying body for the natural gas infrastructure industry, successfully pushed for the adoption of residential heating codes that mandated centralized, ducted heating systems in new construction across most of the United States. The language was about safety and standardization. The effect was the systematic elimination of supplemental radiant and point source heating alternatives from new homes. This is not a conspiracy theory. The AGA spent $340 million on lobbying activities between 1998 and 2022 alone, according to Open Secret's federal lobbying data. What they were buying consistently was code language that makes alternatives harder to use and harder to know about. Here is the comparison that should make you angry. A natural gas forced air system costs between $3,000 and $7,000 to install. It requires a gas line, a flue, a duct system, a thermostat, and ongoing maintenance. It loses up to 40% of its heat output to duct inefficiency. It produces a monthly bill. It requires licensed service. Every component of that system generates revenue for someone: the installer, the utility, the parts manufacturer, the service technician. The clay pot costs $6. The alcohol costs 8 cents an hour. There is no subscription. There is no meter. There is no service contract. There is no billable relationship anywhere in the transaction. That is not why it works. But it is exactly why you have never seen a Home Depot end cap display telling you about it. Here's exactly what to buy and exactly what to do. You need 2 terracotta pots. The inner pot, 4 to 5 inches wide, any standard garden variety. The inner pot can have a drainage hole. It does not matter. The outer pot, 6 to 8 inches wide, also standard terracotta. You also need 3 small bricks, stones, or metal bolts to use as spacers. They elevate the outer pot about a ½ inch off whatever surface you set it on. That gap is mandatory. It is where the cool air enters. For the fuel container, a metal tuna can, a small cast iron ramekin, or any shallow metal dish that fits inside the inner pot. Do not use plastic. Do not use glass. Fuel, 70 to 90% isopropyl alcohol, available at any pharmacy for about $2 to $3 per liter. Fill the container to about half full, roughly 60 to 80 milliliters. That is your burn load for 1 session. Setup. Place your fuel dish inside the inner pot. Balance the inner pot on a fireproof, heat-resistant surface: a ceramic tile, a cast iron trivet, a concrete block. Set the outer pot upside down over the top of the inner pot, resting on your 3 spacers so that gap at the base is maintained evenly around the perimeter. Light the alcohol. The system takes 15 to 20 minutes to fully heat the clay. During that window, the heat output is modest. After that, you will feel it. The outer pot surface will be very hot to the touch. Do not touch it. Keep it away from anything flammable by at least 18 inches in every direction. Never leave it unattended. Never seal a room completely. Some air exchange is required for combustion. 1 fill of fuel burns for roughly 4 to 5 hours. The clay retains heat and continues radiating for 20 to 30 minutes after the flame dies. Total fuel cost per overnight session, under 50 cents. That is it. No installation. No permit. No subscription. And here is where my brain would not stop. Once I understood the thermal mass mechanism, the idea that clay absorbs radiant heat and re-releases it slowly, long after the heat source is gone, I started seeing it in places I had been walking past my entire life. The first place? Bread ovens. The reason a wood-fired pizza oven or a traditional bread oven holds its heat for hours after the fire dies is not magic. It is thermal mass. Professional bakers know that a properly built masonry oven, stone walls 4 inches thick or more, will hold baking temperature for 6 to 8 hours from a single fire. The clay pot heater is doing the same physics at a fraction of the scale. That is why it keeps working after the flame goes out. The second place, passive solar design. Architects who build energy-efficient homes deliberately place thermal mass materials, stone floors, brick interior walls, clay tile, on south-facing walls where afternoon sunlight hits them. A 2019 study published in the journal Energy in Buildings found that thermal mass walls reduced peak heating load by up to 42% in well-designed passive solar homes compared to equivalent insulated wood frame walls. The sun charges the mass during the day. The mass discharges through the night. No fuel, no bill. The third place, and this is the one I could not stop thinking about, vehicle heating. The clay pot heater became a significant topic in the van life and off-grid vehicle community precisely because it works in enclosed spaces with minimal ventilation risk when used correctly. A single overnight session in a cargo van or camper using 70 milliliters of isopropyl burns clean enough that a cracked window handles the air exchange. Dozens of overnight wilderness travelers use this as primary heat in temperatures down to the low 20s Fahrenheit, not as a party trick, as actual winter survival heating. And the wildest data point I found? Medieval Scandinavian log cabins used packed clay and stone in their central hearth structures, specifically because test reconstructions, done by researchers at the Norwegian University of Science and Technology, showed that a properly designed clay and stone hearth could maintain above freezing interior temperatures for 48 hours after the last fire, in external temperatures below minus 20 degrees Celsius. 48 hours from one fire. The mechanism is not new. The decision to ignore it is. What you just learned is not a camping hack. It is a physics principle that the entire residential heating infrastructure of the developed world was specifically designed to route around, because routing around it is what generates revenue. The chimney effect, thermal mass, and radiant heat transfer are not edge cases. They are the foundational mechanisms behind every efficient heating system ever built, from Roman underfloor heating to passive solar architecture to modern radiator design. The clay pot heater did not fail to become mainstream because it does not work. It failed to become mainstream because it works forever on 8 cents of fuel an hour and cannot be metered. You now know the mechanism, you know what to buy, you know what it costs. And the next time your heating bill arrives, you will know exactly what that bill is paying for, and exactly what alternative the industry spent 70 years making sure you never thought to ask about. $6 and a lighter. The rest was always just infrastructure. I want to be clear, I grew up in Quebec, Canada, where winter is not a season so much as a personality trait the province develops. I've paid heating bills that felt like a second mortgage. I found out about this method 3 winters ago and sat in my kitchen for a full minute just staring at 2 clay pots thinking about every heating bill I had ever paid. If you made it this far, go buy the pots tonight. Most hardware stores have them in stock year-round. And if your neighbor sees you walking in with 2 terracotta planters in November and asks what you are building, tell them. They will not believe you until they feel it, then they will also be angry. See you in the next one.